Here we go. Homework 21. Learn Newton's method. Let's dive right in. We have a lovely recipe right here. We guess a first approximation to a solution of the equation f of x equals 0. Keyword guess. I like to call that the seed. Pick a wisely sought out seed. Sometimes you can use a graphing calculator to see, approximately where the function crosses the x-axis to guess a good seed. Use the first approximation, or seed, to get a second, and the second to get a third, and so on and so forth, using the following formula. Now, if that's a little blurry because of the font, I'm going to write that. That's x sub n plus 1 will equal x sub n minus the function evaluated at x sub n over the derivative evaluated, so f prime of x sub n. So we're going to use this on this following problem to estimate the one real solution of this equation. Start with x naught equals 0, a seed of 0, and find x sub 2. All right. Well, I'm actually going to hit pause and pull up a blank slate for that. You see I have hints here, but I want to do that in real time. Okay, so we're going to consider this piece here to be our f of x. So f of x equals x cubed plus 7x plus 3. I'm going to see if I can change my pen color here to black. F prime of x, I always like to lay this out, would be 3x squared plus 7 then. And I like to lay out all the important components of the Newton's method. F prime of 0 would clearly be 7. And the function evaluated at 0, and again 0 was our initial guess, is 0 plus 0 plus 3, which is 3. Now if we lay out Newton's method then, x sub 1 would be equal to your initial guess, 0, minus the function evaluated at the initial guess over the derivative evaluated at the initial guess. So if we keep crunching that, that's 0 minus 3 over 7, which is clearly then x1 is negative 3/7. Now let's go back to the previous slide, and you can see I have here x1 laid out for you. x1 is negative 3/7. And then in a very similar manner, let me just slide that right on down. In a very similar manner, and let me erase all this penmanship here, you can go ahead and compute x sub 2. So x sub 2 then would just be what you had gotten. Then I'll just lay that out over here. X sub 2 would be x sub 1, which was negative 3/7, minus the function evaluated at negative 3/7 over the derivative evaluated at negative 3/7. So you would just carry that on and so forth. And voila. We have that written out over here. A lot of number crunching, as you see here, but you will eventually arrive at negative 0.418. Now, let's see, note to self, how close is that to where this function hits the x-axis. So I'll hit pause as I actually take a real live video of my graphing calculator. So you see here what I've done, and I'm doing this in real time. I'm using this new app to show you. I have my graphing calculator. I've typed it in. I'm going to hit graph, and I'm just going to explore, where that hits. So let's hit trace. I'll zoom in here so you can see. Let's hit trace, and then hit second calculate. Let's go down to 0. I'll hit enter. And left bound, just scoot to the left of where it hits the x-axis. And then it asks you right bound, scoot to the right. I'm using the arrow keys on my keyboard down here. You see those arrow keys. But you can use the arrow keys on your calculator. Right bound, hit enter. guess, hit enter. So you basically hit enter 3 times, negative 0.418. And here's a cool feature of this app I'm using. I'm trying to keep the camera still. Negative 0.418 is exactly what we got when we used Newton's method. So Newton's method has lots of uses. Finding zeros of a polynomial, finding nth roots, solving equations that would otherwise be hard to solve. It's got all kinds of purposes. All right, I'll hit pause as we go to the next problem. Okay, in this next problem, it says use Newton's method to obtain the third approximation, FYI, the third approximation is really x sub 2, of the positive fourth root. So that means the fourth root of 7, positive fourth root, by calculating the third approximation of the right of 0 for f of x equals x to the fourth minus 7. Start with a seed of x naught equals 1. So there's our seed, our initial guess. Okay, so I have some hints obviously here. I say, you know, graph it, look for where that that positive root is, and I have some computation sort of pasted in here. But let me hit pause as I do this in real time on the next page. Okay, here we go. So notice I laid out the function, its derivative, the derivative evaluated at our seed that we were given, our initial guess of 1, and the function evaluated at 1. Note to self, plug and chug. Now we're ready to, you know, use Newton's method. So then x1 would have to equal 1 minus our function evaluated at 1, which is negative 6, over the derivative evaluated at 1, which is 4. Keep crunching that out. You're going to have 1 plus 6/4, which, if you crank that out and get a decimal, you're obviously going to arrive at 2.5. Okay, now let's go back to the previous slide. You see here, x1 is 2.5. I just want you to see that in real time. And then in a very similar manner, if we wanted to go and get x sub 2, which is the goal of this problem, then we'd have to take 2.5 minus the function evaluated at 2.5 over the derivative evaluated at 2.5, so on and so forth. And clearly we would crank that out, and you can verify eventually you're going to arrive at 1.987. Now, what's interesting is that's just an approximation to the fourth root of 7. But let's take an actual look. I'll pull up my virtual calculator here. I love this live camera feature of this app that you can see me typing this in. So I've typed in 7 up caret 1/4, hit enter, and you got 1.626, right? Which in your mind you're thinking, gee, that's way off of 1.987. But remember, you only went to you only took it as far as to x sub 2. If you kept going, you could get a higher degree of accuracy, way out to 5, 6 decimals if you like. All right, I'll hit pause as we try the next. And last but not least, this is our last homework problem for this set. At what value of x, or values plural of x, does cos x equal 11x? Use commas to separate answers as needed. Well, I pasted in a little snapshot there of Wolfram Alpha, but know that this is the same thing as solving cos x minus 11x equals 0, which is exactly what Newton's method is good for. So we can consider this, I just want to lay this out for you, we can consider this to be our f of x, cos x minus 11x, and let's lay that out. Then f prime of x would be equal to negative sine x minus 11, and then we could use an initial guess. Boy, we could use an initial guess of lots of things, really. Negative 50, negative pi. But let's say we use an initial guess of Now, what the computer does is use an initial guess of -50. It just picked a random number. See how quickly it can. The smarter initial guess you use, the faster convergence should happen. So I just want to say that you would want to find f prime of x naught, and you would want to find f of x naught, where x naught is, I'm just going to say, some initial guess. But with this particular problem, I just really wanted to show you how lovely Wolfram Alpha will do this for us. Now I'm going to pull up the live camera here in a sec. Let me hit pause. So you can see here I've got the live feed going, and I typed in, I'll zoom in there so you can see, I typed in solve, oops, I wrote so. That should have said solve. Solve cos x equals 11x using Newton's method. Let's just see what it'll do for us. So when it's midnight and you have nobody to help you with your homework, always remember Wolfram Alpha is there. Let me zoom in on that. So it says, you see, it says the result is x equals 0.09. And it even shows you what we had said earlier, that x sub n plus 1 equals x sub n minus the function evaluated at x naught, and over the derivative evaluated at x naught. Now what's really neat feature, and especially if you have the pro version of Wolfram Alpha, you can page down, and you can hit, it says to 5 steps, you can hit more. Look at that, and it'll show you, look at that, it used an initial step, x naught, of -50, and look how quick it converged to the, sorry about that, a fine degree of accuracy. So I'll circle that with the pen. So by the 5th step, you know, you're getting a very fine degree of accuracy right there. Okay? So know that, just know that Wolfram Alpha does a fine job of crunching those numbers for you. All right? Hope that helps. Good luck out there. Oh, I lied. I did want to mention, I'll hit pause as we do it. We're saying 0.09, right? We do want to practice putting that original function into the graphing calculator and seeing that that does look like a possible 0 of the function. So pardon me if my camera's wobbly. I'm trying to operate something with my left hand and something with my right hand. So what I did was, let you see it, I just went to y equals, typed in cos x minus 11x, and hit graph, made sure I was on the trig window, made sure I was in radians, and then you could see trace, if I hit second, if I hit second calculate, basically, by now I'm assuming you're familiar with that feature of the calculator, and go down to 0, and it asked me left bound, hit enter, and then it asked me right bound, scoot to the right, and hit enter, and just hit enter again. And you see 0.09, that's very close to what we got on the 5th iteration, 0.09. All right. Good luck out there.